All right, today we're going to begin our look at section 3H, where we're going to be talking about similarity and scale. This is a bit of a change of gears from the geometry that we've been working with, but it's still a section of geometry. And you've probably dealt with situations where you're dealing with similarity and scale before, but if you haven't, don't worry. We're going through the entire thing. The first thing we want to do is we want to talk about what it means for figures to be similar. There are two things that you need to know about these. So you have the same shape but different size. If you go from a smaller figure to a larger figure, this is said to be scaled up. If you go from larger to smaller, then that's said to be scaled down. And you're going to be asked questions about that. Was the figure scaled up or scaled down? All you have to do, again, is just look at the shape. Now, the two things that you have to make sure of when you're dealing with these to make sure that there's similar objects. Now, most of the time, it's going to just tell you these two objects are similar. So then you don't have to test it. But there are two tests that you could be asked to do. The first one is that all of the corresponding angles are the same. So you have to be careful that the shapes are oriented in the same direction, right? So you can compare those. Now again, this is not going to be a problem for you in this particular set, but you do realize that they do, right, give you complex, unfamiliar situations where you might have to measure, just decide that things are similar based on this information. Okay. The second one is that the corresponding sides are proportional. And we'll define that word in just a moment. I'm going to define it in a way that, using another word that you may or may not remember. They are proportional. In other words, they have the same ratio. Now, it's important that you understand the vocabulary of these. You're going to see this quite a lot. Proportion is one of the most powerful tools in mathematics. Really amazing things that you can do. So what we'll do is, first of all, we'll just talk about what a ratio is. You've seen ratios since the beginning of your maths career. A ratio is simply a comparison of two numbers. You do this all the time. You hear it all the time. It can be given to you in words. For example, you could have a 2-to-1 ratio. You can also see it written with a colon. That is also another way of writing it. And that's literally just meant, you just read that as 2-to-1. And the most familiar way, and the way you would use it if you were going to be doing math with it, which is what you're going to be doing, is you can write a ratio as a fraction. And once you do that, then all of the fraction rules take over. And the most important fraction rule is that you always simplify them. Divide away any factor that's common to both the numerator and the denominator. Remember, numerator always means the top number, good, and denominator is always the bottom number. And numerator and denominator are always abbreviated capital N and capital D. So later you'll see that you use those abbreviations. So a ratio is simply, if you're going to use it and do math with it, it simply means a fraction. Now what's important is when you're comparing them, you have to make sure that you're getting the ratio in the right order. Because you don't want to get 1/2 when you mean 2/1. Okay? So you need to pay attention to order. And when you're doing similarity, it's always the measurement from the new shape over the measurement from your old shape. Or your original shape, if you prefer. Right? So the one you started with is always the base. Everything is based on the old one, or the original shape. And the new one is always going to be in your numerator. Okay? You've got to make sure that you get them in order, in the proper order, or it won't work. All right? Now, if it's given to you, say like this, as 2 to 1, then it's the first number goes on top, the second number goes on bottom, right? But if you're looking at a shape and you see you're being told to pick and to create a ratio, it's always the new one over the old one. You also want to make sure that you're comparing the corresponding sides. So again, that might mean occasionally on really complex problems, you might have to rotate this figure until they look alike. But usually they're just written side by side and they already look alike. So let's look at an example of what I mean by that. Let's say we have two rectangles, We'll say that this is 3 centimeters, this is 2 centimeters, clearly not drawn to scale. Then we have another rectangle, and this is 6 centimeters, and this side is 4 centimeters. And we are told that these objects are similar. And since I know they're similar, I don't have to test for it. I can simply plug in the numbers and find what I need. So the ratio, there are 2 ratios we can do here. First of all, 3 is bigger than 2, right? So the side with 3 is the longer side, which we usually call the length. So the ratio of the lengths of these, again, remember, it's always the new one over the old one. Length is typically in a rectangle, that's the longest side. So the longest side in the new rectangle is 6. The longest side in the old one is 3, so that's 6 over 3. 6 and 3 will both divide by 3, so you'll get a new ratio of 2 over 1. And would you ever leave a number over 1? No, we just simply say 2. In other words, 6 divided by 3 gives us 2, right? Okay, so that's the ratio of the lengths, but we can also find the ratio of the width. And remember, it doesn't really matter which one you call which. We're just comparing sides. And what you're going to notice is if they're similar, the number is going to come out to be exactly the same anyway. So the shorter ones, that's these. So from the new one, that's 4. From the old one, that's 2. And 4 over 2 will both divide by 2, so that's going to give you 2 over 1, which we can simplify as simply as just 2. And notice that the ratio of both of them simplified to give you exactly the same number, right? If it doesn't, then you've done something wrong. Okay? They'll always give you the same number. And that simplified version, because it doesn't always come out to be a whole number. If you divide 3 by 2, you're just going to get 3 over 2, right? So you can still, of course, get a ratio that's a fraction. But that simplified version is called the scale factor. So if you're asked to find the scale factor, that just means create a ratio and simplify it. Okay? Factor means multiply, and scaling means to make something bigger or smaller. So the scale factor simply means the number that you would multiply to make the object bigger or smaller, depending on if you're scaling up or down. Okay? All right. There is also a scale factor for the areas. And if you know the scale factor, then you can find the area scale factor. You simply square the original scale factor. Because area is a square measurement, right? So all we do is take our scale factor, and square it. So for example, if my scale factor is 4, Then if I want the area scale factor, that's just 4 squared or 16. Our second job is that we're going to be sometimes given similar shapes where we have unknown values. And to solve that, we're going to use what's called a proportion, which again is one of the most powerful tools in mathematics. So, to find unknown values in similar objects, and these are going to be polygons, so squares, rectangles, triangles, that kind of thing. Because we've been working with polygons, that's what you're going to be working with here. To find the unknown values in similar objects, what we're going to do is we're going to use something called a proportion. A proportion is simply one fraction that equals another fraction. And we've already demonstrated that when objects are similar, the ratio of their lengths is equal. So the ratio of the long length came out to be 2 in the last one, right? And the ratio of the small lengths also came out to be 2. So we know that those two ratios, those two fractions, are equal to each other, even though they have different numbers, right? And instead of just simplifying it and then multiplying to find this, we can use what's called a proportion to find these. So what you've got is you've got sum A over B equals sum C over D. So this is what a proportion looks like. One fraction equals another. And one of those values will be an unknown value. Now you can't do it with more than one unknown. You can have only one unknown value. And to solve it, what we're going to do is first, you're going to simply cross multiply. If I could spell it. So for an example, in this one, I would take my A times my D and my B times my C. No, y'all aren't used to the dot. Sorry. I'll use an X for multiply. So A times D and B times C. So all you're doing is cross multiplying. Okay. And what happens when you do that is you end up with a simple linear equation. And to solve it, you simply divide by the coefficient of the variable. Because one of those is going to be an X or a Y or a whatever, some letter, some unknown. I don't like to use X for these because y'all use X as a multiplication, but y'all are used to writing it with this squiggly X. It's fine. But you just divide by that. So if you get used to these, what happens is if you do the multiplication in the right order, if you do the multiplication of the two numbers that don't have an unknown, and then just divide by the other number, you can do it in your calculator really fast. And again, I'll show you what I mean by that when we do an example. Okay? All right. But again, make sure that you create your proportions in order. So for example, you're going to do some where you're working on scale on a map compared to scale in the actual world, right? So a scale on a map, you might have 1 centimeter is equal to 30 kilometers or something, right? So as long as you put them together, so like you could put the map number over the actual mileage or the actual kilometers, and that's fine as long as you also use map over actual on this side. For scale for similar figures, remember it's new over old. So if you put new over old on that side of the proportion, it has to be new over old on this side of the proportion as well. Okay. All right. Okay. Well, that's a scale on a map, and we're going to look at we'll look at some examples of where those numbers come from. So you have a number on a map, so like centimeters on a map equals so many kilometers in the real world.